olefins that you make for natural gas, and then you use the oxo process typically. And when you look at the average, it's about $1,500 to $2,000 a ton that it costs to produce them, whereas we can produce them for less than $500. So that's where we have the cost advantage over typical production technologies of these acids. And so now the markets for these acids, what are they used for? I mean, there's many different applications. You have animal feed supplements and preservatives, herbicides, pharmaceuticals, flavor and fragrance, emulsifiers and thickeners, lubricants, coatings, plasticizers, resins. You know, there's a huge market where these acids are presently applied. The size of these markets for the fatty acids is about 8 billion. Now, once you start going into the derivatives, which I mentioned, we have a rich chemistry at our disposal to do that. Now you're talking about a 500 billion market. So we have a lot of space to play with. And of course, if you ever want to go to fuels, that would be a pretty large market as well, 2.3 trillion, as everybody knows. So, so here's the interesting thing. When you're typically, I come from a background where we're trying to develop a fuel technology, and we were basically forced to build a very large facility very quickly and to scale up, taking many risks and taking many leaps of faith as well. And so that was a big issue because that has represented the demise of several biofuel companies that we're working on. What this has allowed us to do is that we are able to be profitable even at tiny little scales. So for instance, our first demonstration plan is going to be 8 tons per day, but it's going to be profitable because we're going to be catering to the flavor and fragrance market, the food grade market. And then the next stage, we might go to the commodity chemicals, and at that stage, of course, we would be much larger, and we would have attained economies of scale that would allow us to still be profitable. And then so on and so forth, we continue to go to other chemicals that have a larger market, of course, but lower price, but still allow us to maintain profitability all across the engineering scale-up process. So again, just to reemphasize our deployment strategy, first the 8 ton per day facility that goes to the flavor and fragrance and maybe a little bit to the commodity chemicals as a test. And then later on, as we move on, we do the 30 ton per day facility that will go to the commodity chemicals. We produce products for the commodity chemicals. Now the feedstock, for our demonstration facility, we plan just to use purchased feeds, corn, soybean meal, molasses. But once we go to the larger facilities, there's a lot of food processors like palm oil and things like that, where you can get effluents that can be produced, that can be used in this process. So an economic snapshot, you know, the 8 ton per day facility, it's about a 50% return on investment. And of course, that caters to the flavor and fragrance industry. And then the ag and industrial market will be catered once we get to the larger facility. And again, that would be a 43% return on investment according to our calculations. So just to summarize, we want to be the sustainable platform for the chemical industry in the 21st century. And we know we can produce very cheap and inexpensive fatty acids that can be used to produce hundreds of chemicals, as I mentioned. We can use any renewable, wet or dry organic feedstock, so we could start with waste, but we can move on to you know, crops in the future. And of course, we produce green EU and US certified natural bio-based chemicals. And we're, of course, highly profitable. So our technology is very simple. We don't have any of the fancy metabolic engineering or genetic engineering that goes on. But I'm going to leave you with a phrase from probably the greatest inventor of all time, Leonardo da Vinci. He said, "Simplicity is the ultimate sophistication." Thank you very much for your time.
Thank you, Cesar. Absolutely spot on 15 minutes. That was fantastic. Thank you very much. Now I'd like to welcome to the stage Marcel van Berkel. He has a background in chemistry and business administration. He's worked for Solvay, and then he moved on to DSM, where he spent 25 years. Leaving very recently, last year he joined GF Biochemicals, where he is the Chief Commercialization Officer and His current mission is to take levulinic acid to commercialization.
Exactly.
Thank you very much.